Hi guys, my name is Ian, and this week I'm back with my homework solution for lesson number 16 in Paul McWhorter's Arduino with Python series. It's a bit late this week, there was a lot to do and I didn't have as much time as I thought. Anyway, there was a lot to do. We are looking at some Arduino code, we're looking at some hardware, and we are looking at some Python code, and we're looking at it all running together again. So plenty to do, let's get on with it. Right, here we have some Arduino code. Now, this code is built on the code I had for lesson number 12, so if you look back in the GitHub for that, you can see where I've started from. I'll not go through everything I've done in this code. I will highlight where I've had to make changes and what changes I've made, etc. So first thing to highlight is we have got different defines for different things on different pins, so let's have a look at those things. We've got the joystick, of course, X, Y, and the button, that's the Z. Then we've also got 3 LEDs, and we've got a buzzer. This is a passive piezo buzzer, and we've got the heartbeat LED, so I know my nano's happy. So joystick you know about, you've seen it. What are the LEDs doing? LEDs are displaying a binary value, 0 to 7, because there's 3 LEDs. So that corresponds to the rooms in the arena design that I've got in the Python code. You'll see that later. Effectively what happens when the ball moves into a room, the room number is lit up in these LEDs. What's the buzzer for? Well, the buzzer's doing a couple of things. I put in a wall bounce thing, so every time it bounces off a wall you get a small beep on the buzzer, and every time it moves from one zone into another you get a different beep. There's 2 types of beeps, a high and a low. I'll show you that code in a bit. So building on lesson 12, we've got the same millis loop, and we've got these job cycles. I've repurposed some of the job cycles and changed the timing. So for example, reading the joystick is twice as fast as sending the results to the joystick results to Python. That will become apparent in a minute when I explain why. And then we've got the receiving the serial commands. That's the instructions for the LED and the instructions for the buzzer. And then of course we've got our heartbeat LED and the watchdog as usual, resetting the watchdog. No changes in this. Got different setups. The only interesting thing to note in the pin modes is, look at this one. That's applied a pull-up resistor. Now there's other ways of doing this, but I think a pull-up resistor makes it easy to understand what it's doing. But essentially the joystick button pin is floating unless you pull it up to something, and there's a built-in resistor in the Arduino, so I'm using that. It saved me a few components and a bit of time. So into the main loop we're setting up a bunch of values. We basically got the values that we are going to use for the joystick, the X, Y, and Z, and we've got the old values as well for X, Y, and Z. That will become apparent why that is in a minute. Then we've got some information about what the action for the LED will be. That'll be the number 0 to 7. And then we've got a double action for the buzzer. That's quite interesting. I'll show you the code for that, but essentially you send over one action, but there's 2 pieces to it, essentially a letter and a number. The letter can be H or L for high or low, and the number is the duration. So that's what Python sends. We'll see that in the Python code in a bit too. Okay, into job number 1. This is where we are using our old and now values. Essentially what we're doing is every 25 milliseconds we're reading the joystick, but what we do for the X and Y values is basically take the average of the past 2. So it needs to know what the old one was, it's got the now one, and it works out the average of those for the value that it's going to send to Python. It does that for the X and it does it for the Y. The The switch one is a little bit different. There's a now and an old value for it too, but what it's doing is not averaging it all, not at all. What it's doing is if it gets a button press for two samples, as in the now we've just looked at and the one before, if they're both the same, then we know the button's been pressed. That's basically it. What that's doing is a bit of switch debouncing. So basically that means you have to hold the button down for at least 25 milliseconds for the button press to be noticed. I found that was good enough. I'll show you what the button's for later on as well, because you might be wondering. So excellent. We send the results out. This is same sort of code as what we had in lesson 12. I'm just sending different things, constructing the sprintf with different numbers to send, working out a checksum as we did before, slapping it on the end and sending it on its way. Excellent. So here we now have parsing of the received commands. This is similar sort of stuff as last time, in that we extract the command and the checksum set using this magical string to token. We extract the commands, the checksum. If there is a checksum and it passes, then we proceed. With the command, we extract a subject and an action, again with string talk, working through the buffer using the delimiters that are all defined upstairs. The interesting thing is it extracts simply, an action for the LEDs if it spots this keyword. The keyword for the buzzer is beep. Yes, I know, original, but it made sense to me. And then what it's doing in here is a little bit different. The command after the equal sign for the beep, I'll demonstrate that in a minute. Basically that command is a letter and a number, a letter R and some number. So it could be, for example, H100 for a 100 millisecond high tone. It extracts the note, as in the high, by basically taking this char and assigning it to the contents of where the action pointer points, which will be the first letter of the action, as in this H, or in my case H or L. Then what it does to get the number is it sends the rest of it, action point plus 1, which is the next character in where action points to, sends that to the command to turn it into an integer, this string to integer command. So it's got those two. What this is about is you can send more than one command in a string at a time, assuming the buffer doesn't overrun a lot. So you could send a LED and a beep command in the same command string with return at the end. This will allow you to cycle through extracting out multiple command subject action pairs. So that's what that'll do, and it keeps going round while it doesn't hit a null. So as in, if you've hit if these evaluate to a null, then you know you've hit the end and there's no more. So that will bomb out. That stops the while loop. But while in this loop, it'll keep reading until it runs out. And of course, it won't be reading for very long, because the command buffer is only 32 bytes. But you get the point. Next, it does something with them. This is where it displays the LED action on the LEDs. That's just, it calls the function, passes over the number. I'll show you how that works. This is a similar sort of thing for the buzzer. It calls the function and passes over the two things, which is the note and the buzzer, the duration. So it's the note and the duration. Then we've got our heartbeat stuff. That's the same serial event. Serial's how it's capturing stuff through an interrupt built-in function of Arduino. Very, very handy actually. This is the LEDs. Basically works through the binary value. If bit not of the binary value is an odd or a 1, it turns the first LED on or off. Similar for bit 1 and bit 2. Here's the buzzer. It gets the note, the duration. It checks is the note low or high, and if it's a low note, it uses the tone function, which is what you can use. It's an easy function to use it's an Arduino command that you give it the pin the buzzer's on, the frequency in hertz, and how long you want it to go for. And then it's another built-in Arduino interrupt thing, so I don't have to come back and turn the buzzer off. It's got the duration, it turns itself off. Great. If it's high, it's just 880 hertz instead. I made those up. I think that's an A4 note, and then that was double it, so that was easy. So that's the code running. Let's have a look at what the hardware is and what the code is running on. So let's change screen and show you some hardware. So there we have my Nano on a carrier board. Yes, this is new. This brings out all the Nano pins with loads of grounds and 5 volts all over the place. Very, very handy. Only cost me a few pounds. So I'm running my Nano on that. I've got lines over. I've got the 3 LEDs. That's bit 0, bit 1, bit 2. The resistors that always go with an LED, I think the 330 ohms. That's the piezo buzzer. It's a passive one. You can get passive and active. Passive one's just what I had to hand. And then of course we've got the joystick, and that's wired up exactly the same way as Paul has wired his up. There we go. Now let's have a look at some Python code, because that's spent a bit of time on that too. So we go back to the software, we change screen so you can see what I can see. There we go. Now there's quite a lot changed in this. If I show you what the arena looks like first, this code will make more sense. So the arena is going to look something like, not like that. That's what it's going to look like. So the arena is going to look like that. So we've got, you can see there, there's looks like a tunnel of boxes. These boxes are all unit size boxes. There's 3 deep and one at the clink in them at the rear. When we get into the active picture, I'll spin it around. There's a ball can run up and down. It's bouncing off all the walls. There's 2 pads, 2 bats. One's red, one's grey. That's what the button's for. You can switch from bat to bat, and whichever one is the red one happens to be the one that's active, and the joystick obviously moves the bat around the front of whichever cube you've got the active bat in front of. So that's what it's looking like. We jump back to the software now and we'll run through it. So these unit cubes, as I say, they're all the same. It's just depending on which one it is, it'll be in a different position, or it will have different walls turned on. Some like the one at the front, the arena box number 1, the wall at the front and the rear, they don't exist because the ball goes up and down the tunnel. So how we're doing that is basically this side here, and if we're going to do the left hand wall on which is the X minimum wall, that's the one there, and you can see how right is the next one, and so on all the way over to you've got the back and front, and you've got these, and it's all just a bitwise number. And I can also print a name inside the box, as I know which one it is, or if you send over nothing. Now that's the cube, drawing the cubes to make the arena. I then have drawing a bat, and it's a class, whereas that's just a function. So the class for the bat is because I need to change things with it after the fact. So this is the easiest way to do it. You can call the update functions. I change the color, obviously, whichever one's active, that's the red one, we'll have to change the color, and obviously as I move the joystick I have to change the position. So that's what all this is about. This is so as I can get the bounds of the box, of the bat. At the minute I'm not using it, but I suspect I might need it. It's similar to know the bounds of the boxes themselves for whenever we do the zone and boundary checking for the ball when it's moving. CRC code lifted from the previous, I think, lesson 12. So this is where I'm drawing all my zones, and this is where I'm constructing this arena for each of these boxes I'm drawing, and I'm working out where to put them. And you see I'm all setting them all around. The zone size is 10 as it happens. It could be 1. It's all the same. It actually doesn't make any difference. It all just looks the same, but it's used in the scaling of things. So you see I'm just putting them around, pivoting around a center point, drawing a U-shaped around a center point. That's what this is all doing. Then I'm putting a bat at each end of the zone 1 and zone 4 as it happens. I draw a ball. I'm giving the ball an initial change vector of this. I found that this was a pretty good one. Gets the ball moving quite fast in and around all the zones. I print out some information for myself so that I could do the 3D checks, the calculations myself. I'm connecting to an Arduino, so I've got my serial code from lesson 12, except I've taken away the could not connect for that went over the top of my meters previously. Now I'm just setting serial, not found a print for that. I set up some initial variables. These are used down below, so depending how things run, I'm defining them first so that I don't trip up by using it before it's defined or doing things like that. This is an interesting one. I basically have a variable up top which allows me to turn this buzzer on and off. What I found in testing was that the constant beeping gets very annoying very quickly, but I still need to do the testing. So I give myself a way of turning the buzzer off, and basically all I do is there isn't like an on-off switch for the buzzer, but if I set the durations to 0, the Arduino code knows not to do anything. I've got checks in there for the duration being greater than 0, and if it's not greater than 0, it doesn't actually call the function to do the beep. So that's how I control that. I set the initial bat I'm going to use. I just chose bat 0, which is the left hand one as it happens. This is into the code we've seen before, where we capture the incoming serial from the Arduino. We start splitting it up, doing the checksum checks, and then eventually extracting the 3 joystick values for the X, the Y, and button Z. I put this in for my own debugging so that I could see that data coming in. If the checksum the CRC fails, it complains. The ball moving code is identical to last week, except I've just adjusted it for the zones 1 to 7 that I have. Last week it was tunnels and zones. Well, but tunnel is just a differently sized box in that case, but they're all just boxes, and that's all this is. It's looking to see where is the ball going. Is it going in? Is it going into? Well, where is it going, and where is it now? Because the ball has 2 sides, a front and a back tip, and the front could be in one zone and the back could be another. That's detecting all this. So it's detecting if the ball is in a zone, or if any part of a ball is in a zone, and it sets it true. And it also sets this ball location. That's used later on when I'll show you that. So does that for all 7 zones, because there happens to be 7 zones. And then this is where it's doing the, well, what zone are you really in? It's detecting that if you're in zone 0 but traveling to zone 2, and that's the direction of your travel, well then if part of you is in zone 2, we'll just set all of you to zone 2. That's the way. So you set the ball to be where it's going, and that's what it does. It's doing all these boundary checks for all the different boundaries between the different zones. And then this is where it moves the ball, and it's doing the same sort of checks as before. If you're approaching a boundary and that's the direction you're going to go in, as in you're going to hit the boundary, then it'll reverse it it'll reverse the ball that direction. Obviously it doesn't reverse it if you're already traveling away from that boundary, and that's all the same sort of stuff as last time. Now we have the more interesting stuff. This is testing for whether the joystick button has been pressed, and what this does is it checks that it has been pressed by basically saying if it's down and the old value is not down when you press the joystick button, it's the Arduino sends a 0. So what this is basically doing is detecting a change. Okay, so that if you just hold the button down, the bat won't constantly flick from left or right. It's looking for a change. So if it's down and it wasn't down before, then it's a toggle to get the bat. Then you let it go, and then you do it again, and it'll toggle back. And that's what this code's doing. And as you change from one bat to the other, it makes one bat red and the other one with the default color, which is grey. And it sets the bat variable to be the particular bat that we're in use, which is a bit like the boundary checks up above, where you set a bound variable to be the zone. Well, you do the same thing with the bat. You set the bat variable to be whichever bat you're using, and then this is where you move the bat. And effectively what we're doing is taking the joystick X and Y values and scaling it down from the 0 to 1023 range that the joystick sends, to turn that into something that makes sense in the moving in our box. And effectively what it's doing is it converts it into a number between 0 and 1, or something, 0 and 1, subtracts 0.5, so as we get minus 0.5 to plus 0.5. If you can remember in that the bat's centered in this, and we work from the center of the bat, and the bat is centered in the box. And then we just scale it up. So we've got a number between minus 0.5 and 0.5, and we scale that up for the size of our actual box, which in our case was 10. Now this actually takes the size of the bat into account because we're working from the center of the bat and all that sort of stuff. But that basically is a scaling value to turn our unit value into the size of the arena boxes we're playing with, and then it moves it. And then this is where it sends some stuff back to the Arduino, and this is where it builds the Arduino command. This is where it's if the ball's location has changed, that's that location number that was set here. So it keeps a note of what it was. Keeps a note of what it was in there, as in what it set the LEDs to last time. And if the ball's location has changed, it constructs a new command to send the new ball location. So it sends the location, that turns the LEDs on to the location number, the binary number, and sends a low beep as well of the beep duration, assuming we haven't turned it off because it annoyed us. And then it updates that variable for the next time round. Similar thing for the bounce. If the code here is mutually exclusive, because you won't get a wall bounce at a boundary. When it's moving from one box to another, it won't be bouncing off a wall. But if there is a wall bounce detected, which is a variable set there, whenever we were doing the bounce, the wall boundary bouncing checks, we set that variable. If there is a wall bounce, we construct a command with the high and the duration. Assuming we have a command, which that was cunningly set to false at the beginning, once we start changing it either here or there, that will no longer be false, and then we will get a checksum and add the checksum onto it and send it. Now let's have a look at some of the hardware in action. So let's get to a demo screen for you. Is it this one? No, it's that one. Actually, I think what I'll do is I'll go to this one, and if I also get up CoolTerm. We shall connect with CoolTerm, and you shall see the data streaming in. So there we go, there's CoolTerm. Now let's turn on another screen for you because this will be interesting. Right, so if I connect with my CoolTerm, and there we see the data. Now if I start mucking about, one of the things I did in the code was to correct the y-axis. Whenever this is up to me, so I wanted it to be 1023, that's down in the y, and I want it to be 0. Naturally the joystick actually does that in reverse, so I've in the Arduino code I basically subtract the joystick value from 1024 to reverse it. We've got X, that was normal, and then we've got the button. You see the number at the end, that's the checksum that's constantly changing as the contents of the string changes. So that's that all nice and working. Now if we send some commands, so let's turn on some LEDs. So the command would be LEDS equals, well, let's try 7. Oh, I have to press the send. There we go. So that's 7, and if I do LEDs equals 1 and send, then we get just 1. Now if I do beep equals low 100, and again I have to press send. Now you probably didn't hear that, it beeped. If I send it again with say 1000, that's a whole second, and make it H for high and do send, you probably didn't hear that again. I have no idea. I've been hearing it for days. It's been driving me nuts. Anyway, that's that working. I can send 2 at once, so if I do LEDs equals 7 comma and a beep, that should hopefully light all the LEDs and do me another beep. There we go. So that's all nicely working. So let's stop this, disconnect it, and then we'll run up our Python code. So let's move to another demo screen for you, which is not that one, it's this one. Right, so let's run this code, and you will see a ball bouncing around, and as it moves from room to room you will hopefully see some LEDs and possibly hear a beep or two. Although I think I turned the beeping off. Let me just check my code. Yeah, the beeping's still off. It was annoying me too much. So here we go, it's drawn the arena. If we spin around, you see the 7 rooms. They've got numbers in them so that I could keep track of it and not forgetting or getting confused. And if I show you the joystick as it moves, the bat moves, and if I press the button, it moves over to the other side, and if I sort of get it up there and press the button, it sort of leaves it there, and I can move this one, and then I can leave it there. So it all works nicely, so I'm quite pleased with that. Next thing I think Paul will be doing will be the collision detection, so when the bat actually hits the ball. So at the moment it's actually quite difficult to control. It's a very small joystick, and you sort of like don't have the, what you maybe want is the precision of it, but anyway, it is what it is. That's everything. As usual, any comments or questions, leave them down below, and the code will be on GitHub. That'll be the Arduino and the Python code, and that example picture as well will be all there. as well as the cool term profile thing for the correct baud rate and whatnot. Interesting thing in the cool term, you have to actually tick a box so that when you press send, it sends a carriage return or line feed. By default, pressing send, it doesn't actually add that, so I had to turn that on. That was a scary moment when I thought my code wasn't working. Anyway, until well, it won't be next week. It'll be sooner than that because I'm gonna not try and be late again. Anyway, till next time, have a great day.